Good afternoon, everyone. Thank you for coming to my talk today. So I'm a program manager on our Python developer tools at Microsoft, and today's talk is about how you set up a development environment that's running inside of a container. And for this talk, we'll be building a sample application that uses a somewhat common configuration where you have Django REST Framework API with a React front end and a Postgres database. And to build this application, we're going to use just two dependencies. We'll be using Docker and Visual Studio Code. Now, if you don't use Visual Studio Code, you'll still get a lot out of the talk about all the other pieces here. You'll learn a lot about containers and React and things like that. But the neat part, because we're using containers, you just need these two dependencies if you want to follow along. Now, please don't try and follow along in this room with me. You can follow along with the video afterwards. I'm going to be live coding here, and we don't need gigabytes of Docker downloads to be happening during the talk. So appreciate that. So why are you all here at the talk today? Many of you have adopted or are thinking about adopting containers in your development or production environment. And one of the key benefits of using containers that we hear often is that if it works locally, it should work in production, because what a container allows you to do is run kind of like a mini operating system with all of your application's dependencies in sort of the containerized environment. It's kind of like a lightweight VM running on your machine, and that's typically defined with a Docker file, and you have some tools that will build this container from a Docker file, put your app inside of that, and then run it. And then when you run that app, it does some things, right? And then if you deploy that container to production, hopefully it will do the same things because all of the environmental factors around your app have been put inside of the container. Now, and an additional benefit that comes with containers is you can use containers to acquire development dependencies. So if you need a database, a Redis cache, or a Celery worker, or a bunch of other microservices that your application depends upon, you can throw a bunch of those into a Docker Compose file, and you can use Docker to build a set of containers that you can have locally. So it makes it really easy to create a lot of the complex development environments that we have to work with today. Now, one of the problems that gets introduced when using containers is that boundary, that container boundary. It's a different operating system. It causes many issues for tools. It's really hard to actually productively edit, debug, test, do all the things that you normally want to do when you're working on code. So for example, you have to, typically you might need to rebuild the container every time you make a code change. Autocomplete might not work if you don't have the Python packages installed on your host operating system, which I'll call the local machine. And then your debugger might not be set up to run the app in the container. And for example, your testing framework might not be in the container because these are things that your app doesn't need during production to run. So typically what you would do is you'd create a different container definition for local development. And the thing that I'm going to be talking about today is actually developing fully inside of the container, where some portion of your IDE is actually running inside the container environment, where you'll have your editor UI talking to some backend running in the container, and that backend's working directly with the code, the app, and the development dependencies. So that allows you to work a lot faster, more productive, without sacrificing all the tools that you're used to when you're developing. So to make this concrete, I'm just going to start off with a very low-tech example. I'm going to create a new containerized dev box just from scratch here by running some Docker commands. So with Docker, you can pull down a container just by typing docker run, and we'll say I want to run a bash prompt, so I'll type -it, so run interactive, and we'll give this new container a name, Python devbox, and we'll base it off of the standard Python image that's available on Docker Hub. So you can use any image here. If you wanted a different version of Python, you could say Python 3.6, and then when that container starts up, we just want to run bash. So there we go. I've got a development container. I'm running on a Windows machine, but I've got a bash prompt here. So let's actually install some tools. It's just for fun. So we can run apt-get and then apt-get install vim. So we'll put some vim in here. We're having some serious fun. So it's going to pull the packages down, and then we'll install vim, and then let's write a simple piece of code. We'll go and create a new folder for our app, and then we'll vim hello.py, and then press I to insert some code here. Let's say hello DjangoCon. and then we'll print that message, and then escape, :W, enter, :Q. Yeah, I love Vim. Okay, so we can run that with Python's installed in this container. We can get a nice little Python REPL if we wanted to. Hold on. I shouldn't have done that. I don't know what I typed. Good thing I've got a backup. This is like the one part of my talk that never messed up when I practiced. All right. We'll just restart that. Hello, DjangoCon. And then print that message. And we can actually even debug this running inside of the container. We can use PDB, which is the command line debugger built into Python. So I'll run Python-m PDB, so that will start the PDB module, and we'll debug the file hello.py. So there we're stopped on our line of code, hello DjangoCon. We can step over, we can inspect that variable, and we can step over, and we can see it prints out the message. All right. So that's our nice little dev container. However, there's some problems with that, right? So we have to remember all these Docker commands. I'm not really much of a command line person, so we're limited only to command line developer tools. And in this case, with this simple primitive setup, the code will disappear as soon as the container stops, because containers are kind of immutable. They get created one way. And then right, with just how I've configured this, if I got a website running in the container, the ports aren't exposed. So those are all additional things that I would need to do to make this better. So to solve a lot of those problems, I'm going to show you how we can use Visual Studio Code to get a full feature development environment without sacrificing all the things that we're used to. So if you're not familiar with Visual Studio Code, it's a free cross-platform and open source editor from Microsoft, and it's fast and lightweight, and it has support for multiple languages that are enabled through a rich extension ecosystem. And it has built-in support for JavaScript and TypeScript, and you get the standard features that you would expect from an editor with IntelliSense, debugging, and source control. And then for Python, there's a Python extension that's developed by my team that adds the Python support for those same features like IntelliSense, debugging, linting, testing, refactoring. And this is the most popular extension for the VS Code marketplace. So there's a lot of Python developers that are using this tool. And just so you know, it's developed in the open on GitHub, and we put out a new release every month if you follow our blog. You can stay up to date with all the new stuff that's coming out. So the key reason I'm talking about Visual Studio Code, it has some unique benefits for this particular scenario. It has a unique architecture that actually enables a fully featured, just like local development experience. So Visual Studio Code is built on top of Electron, and it's written in JavaScript and HTML. So it's always had this inherent client-server model, where the back end, all the guts of VS Code ran as a server, and the UI ran as a separate process, what makes it nice and fast. So we announced remote development for VS Code at PyCon back in May, and in this case, what we do is we take that back end, we run it in a different machine. So it can run on a remote SSH VM, and in this case, it's running inside of the container. So you have all of the UI just kind of transparently works, and I'll show what that means in a second. So one of the benefits of this approach is that you can quickly create or switch between development environments. You just clone something, open it with VS Code, and then you could just start working because all of your dependencies are encoded in sort of that Docker container environment. So others can really quickly replicate your environment on a different machine. And then other tools do have similar features. I showed you what Vim looked like, and then there's PyCharm also has remote development support. But for this talk, I'm going to be walking through VS Code, like I said. So that's some background. So for the rest of the talk, what I'm going to walk through is attaching to an existing container, and then creating a new development container, and then adding a React front end to the application, and then finally building the production version. All right, so we just created this command line development environment from the command prompt. Let's actually attach to this dev box that we created with VS Code. So I'm going to open Visual Studio Code here. So the first thing we need to do is install some extensions. Right, so if I go to my extensions tab here, the first extension that we'll need Docker, which I've already got that installed. And this allows us to create and manage Docker containers. And then for remote development, we want to install the remote containers extension. So this allows remote development to work with the Docker container scenario that I was talking about. So once we have those installed, there'll be a Docker icon on this left activity bar here. And that allows us to see all of the containers that we have on our machine, the images that we have built locally, and any registries container registries that we're connected to. So I can see that there's the two containers, my primary and backup one. I can just right-click on this container and say, attach Visual Studio Code. So this will start a new instance of Visual Studio Code, a new UI, and it will install the remote server into that container that I built. And if we look at the details here, it's showing us all of the Docker commands that it's running. It's copying the server into the container. It's gonna, I don't know all the things it's doing, but it's doing a lot of stuff. But the point is that this is all stuff that I didn't really have to think about, set up, and manage. And then once it's finished, now this instance of Visual Studio Code is fully running inside of this container. So anytime I do anything I would normally do with Visual Studio Code, like open a terminal, now I get a bash prompt because that's running in that same container. Now I don't have any files open because I actually need to open a folder. And I also need to install the Python extension so that I can start working with the Python code in this app. So I'll go back to my extensions and I'll search for the Python extension. This time it's saying install, it's asking if I want to install the extension into the container. So when I click this install button, it will install the Python extension, like I said, into the container environment. And then once that's finished, I'll actually open up. And now I need to reload VS Code, but I'm going to open a folder on the container using this open folder button. So there's the app folder where I wrote that simple hello.py script. I'll click that and I'll open. And so reload will then, VS Code will then refresh and open that application, that folder. So when it opens, I'll be able to see my files here, and I can actually start coding. Let's give it a second here. It's a little bit faster the second time because it doesn't have to do as much. So there's that file I wrote from the command line. I can open it. I can select my Python interpreter. I can run this piece of code by going right-click, run the Python file in terminal. I can debug, so I can set a breakpoint. I can click there. And I can go debug, start debugging. I'll select a Python file, and I can inspect variables, and everything just kind of works as I would expect, right? But it's all running in that container environment. So I've got a bunch of slides here that are more for reading offline, so I'll go through them fairly quickly. But just a quick recap: we installed the Docker and Remote Containers extension, and then we right-clicked from the Docker tab and then attached to the container that we had. We installed the Python extension into the container, and then we opened a folder and then did some debugging. So we can run the Python file or debug the code. Okay, so there's still a few problems with this. I attached to an existing container, but again, I haven't solved the problem where my code will disappear or that I haven't set up port forwarding so I can access websites. So the next step we're going to take is we're actually going to use Visual Studio Code to create a new development container and configure it with more features that we need to be productive. So let me just go back here. So to do this, I'll close out this container, and I'll make a new container folder. And what I like to do code dot from the command line to open this folder up. It just runs VS Code in the current location. So now I'm in this new container folder, and to create a new development container, I'm going to run a command in VS Code. So to run a command, you use Control-Shift-P or Command-Shift-P if you're on a Mac, and then like all the extensions add various commands to this menu. So this is where a lot of functionality shows up. So I can search here and say add development container configuration files. And that will let me pick from a set of predefined containers that the VS Code team has built. So if I search for Python, I have a few different versions of Python that I can start with. I could use Anaconda or Miniconda. And then for this talk, obviously, I want to use the one that has a Python image and a Postgres database. So I'll select that. And what that's going to do is going to add a bunch of files to my workspace. Now, this is going to take a minute, so I'm going to click the reopen in container. As soon as those files exist, VS Code says, this is a development container. Do you want to open this in the container environment? So I'll click that reopen in container button there, and while that's opening, I'll just open a new instance of VS Code just to walk through some of the files that we created. So this dev-container.json, this tells VS Code what it's supposed to do with this development container. It tells it, it tells it which file it should use to build the container. In this case, it's going to use a Docker Compose file because it's going to build multiple services. And then it says, which service do you want VS Code to attach to? VS Code will only attach to one of the containers that I'm running. And then, where do you want to mount the workspace? And then you can include additional settings that only apply to this development container. So, for example, it sets where the Python path is. Do I want to turn linting on? And then, most importantly, what extensions do I want to install into the container when it starts up? And then so if I look at the Docker Compose file, and then this is just a pre-built image that the VS Code gives you. It has an application service here, so this defines the different services that Docker Compose will build. And then, so my app is defined by this Docker file right here. So that's the image that's going to be built when my Docker file runs. And then that connects to a database, which is going to be available on with the name DB on my local network inside of this container. And that's just built from a standard Postgres image, and I've set up a simple password that I can connect to the database with. So this container just finished opening. Well, I don't know when it finished opening, but it finished opening. And so now I can start working with it. I've already got Python installed. Let me hide some of these so I can get more space back. Okay, that's fine. So now I can, now let's start scaffolding our Django application. So first I'm going to create a requirements.txt file. That's going to include all the Python dependencies I want. And I'll put Django in that. And then I will install those requirements from my command line. So that will install Django, and you notice that was super fast. I'm pretty sure that these containers have been mapped to volume mount my my Python package cache, so that doesn't need to be recreated for every container I open. So now that we've got Django installed, we can run Django admin start project, and we'll create a new site in this current folder, and then that will give me my Django application. And then I can run that. But in this case, what I want to do is actually, when I'm running this, because it's running inside of the container and I want to talk to it from outside of the container, I need to bind to 0.0.0.0 so that the site is available to external incoming requests. So I'm going to run that on port 8000. I'll get to the migrations in a minute. And when I run, so this won't actually browse yet, but I need to, because I need to forward a port. So I'll run, I did Control-Shift-P again, and I'll say forward port to the container. And it detected that port 8000 is being listened on, so I'll select port 8000. And then I can open the browser, and my new Django application will come up. So we're off and running. Okay. So next I want to configure this to actually talk to my Postgres database that I have. If I actually go back to this container here, my Postgres image is running there. And just a quick tip, you can actually attach a shell to this Postgres container so that if you want to run psql commands, you can just type psql-u postgres, and then this will allow you to describe the tables and run your SQL queries. So now to connect to my Postgres backend, I just need to change some of my settings here. Let's collapse that. we'll use the PostgreSQL engine. And to use that, we actually need to install the Postgres driver, put that in our requirements.txt. And then the database name to use is just Postgres, that's the default. And then user is also default Postgres. And then the host is DB. Remember, that was in our Docker compose file as the name of the image, or the name on the network that our database will be available on. And then finally, our super secret password. And if someone manages to hack into my machine, they're welcome to my sample data. Okay. So now when we run this, so I'll just do a quick. So typically, if this database didn't already exist, you'd have to do a manage py migrate. But the migrations have already been applied. My data is created, and now I can run server again. However, this time I'm going to set up the debugger. So to set up the debugger with Django, we want it to always run that manage py migrate or manage py run server command when we start. So I'll go to the debug tab here, and I'll click add configuration. So this will create a debug configuration that I can use over and over again. I'll start with this Django configuration, and then I will select, so this just tells it how to launch Django, and I'll just add an argument on here that specifies that local port. So now when I start debugging, it'll automatically debug my Django app, and my development server should be running. So we'll go localhost there. And if we go to our admin panel, I previously ran the create superuser command, and there we go. This is all set up with a Postgres database. We have our backend. Now I want to add some APIs to this. So you notice there's some models already built in with Django, users and groups. I'd like to expose those as APIs that I can access as a REST API. I'll call those from my Node backend later. So I'm going to switch to a different container that I've already added some code to. So I'll close this out. And if you're switching between multiple containers, you may want to come in here and just stop your old ones, just because they'll be using the ports that you want. So I'll just stop those. And then I'll go to dev container backend, open this with VS Code. And then I'll select reopen in container. And while that's opening, I'll just make sure it's actually opening, and then I'll go back to some slides. I've hit enough failure modes on this presentation that I know where it's likely to fail. Okay, so just a quick recap of where we are at so far. So we created a new dev container using VS Code, and we did that by running the add development container configuration files command. We selected a pre-existing Python 3 and Postgres container. And then we used the Django admin command to start a new site. And we ran it on the local IP address, and then set up port forwarding. And I didn't cover this, but one thing that I did add to the Docker compose file is to set up that port forwarding automatically, just by adding this this list of ports here, so that every time I open the container, those ports are always exposed. And all right, we'll come back here. I forgot to cover Git, but I'll get to that later. So I've opened this this new dev container here, and so to add the API code, what I've just done is I've followed the Django REST framework tutorial that's available at this link, and I added the Django REST framework package. and I'll just walk you through what that code looks like. So I also did Django admin start app backend to create the backend. So basically what code we added here, first we added some serializers that take those users and groups and tell Django REST Framework how to serialize those into JSON objects. And then we added some views that expose those users and groups as a set of REST APIs. So this defines multiple endpoints for all your different HTTP verbs, your get, update, post, put, those things. And then finally, we added those views as, we've mounted those views at a URL path of API, and we've defined this router and registered it. So again, that's following the standard REST Framework tutorial stuff. So once we've done that, let's go ahead and run the app again. And we'll just see what that looks like now. And so now if I go API, oops. Now we get the Django REST Framework's browsable API. We can go in here and we can click around. We can look at the existing users that we have. We can even create users and things like that. So if I wanted to create a new user, I'll just name him Jeff for whatever reason. That's just what I'm feeling right now. And we'll click post, and then now that user's added to the user list. Okay, so we have an API, and again, that's the code we went through. I'm just skipping through it for now. And so let's just do, while we're here, let's just play around with a few more features of VS Code. So first, I'll configure tests. So if we want to configure tests, again, I can run another command. In my backend, I just have a few tests I've written using unit test. So Control-Shift-P or Command-Shift-P will run the configure test command. And we support unit test, PyTest, and nose. And unfortunately, we don't support Django unit tests, but it's on our backlog. So I'll select unit tests. I'll tell it where those tests are. They're in the backend folder, and they're named test_.py. So once I do that, I can get the testing features of VS Code running here. I can run tests or debug tests from here in code, and I can also use Test Explorer to view and run all of my tests. So I'm getting all this, like I said, all of the kind of features that you have with VS Code, they just inherently work here. So now let's just for fun, let's run the Django REST Framework code through Black to format it, just to see what Black thinks of this code. So we'll run the format document command. You can also right-click and do format document. It'll ask me what format I want to use. I'll select Black. And that will install Black into the container. And now I actually have to run the format document command again now that I've installed it. So Black just added some spaces, and it changed the single quotes to double quotes. Okay, that's interesting. And then, like I said, I've got my source control here, so I can see those changes. And I can actually commit these and push them. When VS Code set up the container, it actually copied my git config file from my desktop. So anything that I have on my local machine, I can implicitly push to and access from the git inside the container. That's another nice thing that I didn't have to set up. All right. So let's go ahead and quickly add the React front end here. So let's close out all these files. So inside of my Docker file, I have actually added, to this one, I've added just some apt-get commands that install Node. I'm pretty sure I got these from the Node website. Just pasted those in here. And then so now this container actually has Node installed in it, so I can use that to build the React front end. To do that, I'm going to use a tool called Create React App. So Create React App is, you know, this isn't your father's React anymore. Like, create. So I used to work with React a long time ago before we had Create React App, and it was just a mess. But Create React App makes things a lot easier because it packages all of the things that React needs into a very small package. So we'll just run the npx create React App command to build a new front end folder. Now again, this actually takes I think like 10 minutes. So I'm just going to cancel out of that and switch to a different container where I've already set this up. This is a get up and go get coffee moment. So let me close that, and then we'll switch over to dev container front end, and then do the same code dot. And then we'll just go ahead and reopen that in the container. And while that's opening, this will take about 30 seconds or so. I'll just start to look at some of the files that we have. So after Create React App ran, it created this front-end folder, and it basically has my input source for React. So React is a, see, I got to stop those old containers. All right, we'll try that again. I think I've confused myself. All right. So also a neat tip, your recent files lets you pick between whether you want to open something inside of the container or if you just want to open the folder normally. So I think, so this one I'll select, I'll reopen this in the dev container. Okay, so that's building. So while that's building, this one, so basically the files in the source folder, those are all compiled into basically from the React syntax into this build folder that we have up here. So this is like this is JSX, which is a mix of JavaScript and HTML. It's a React concept. It's very divisive. A lot of people don't like it, but I personally find it really fun to work with. But basically, this is a new function that just returns a piece of HTML code. I've got my CSS here. I've got some tests and other things. So like I said, all this stuff gets compiled into mangled JavaScript and things like that. And how this works is that there's an index.html, which you can't really read here, but basically this index.html is a static index.html that includes all the JavaScript that got built by React. And so that's the page that we need to return for our users to be able to view the site. And then I think, okay, so this is started. So the first thing I'm going to do is start the node development server with npm start. And so this is going to give me a development server that I can use where I can edit my code on the fly, and then the changes will be immediately reflected in the browser. And but this won't actually build those files that I was talking about. This is just for local development. And this also takes a minute to get kicked off. So while that's running, I'll just do a quick recap. So we added the node to the image by adding these lines to the Docker file. We ran the create React app command, which generated that folder structure over there. And our server is almost ready. I'll get my browser going. So this server is going to start on port 3000. And in this case, right now, this isn't connected at all to my Django application. This is just a node development server that's going to serve up some HTML for me. So, and the reason that I want that is that I can come in to my source folder, my app.js, and I can say, I'll just change some of this HTML code that says, hello, DjangoCon. I'm not very creative today. And if that's all working correctly, it should, it's recompiling, and then the updates show up in my browser. Okay, so I'm going to switch this code over to another branch where I've written a little bit of code to call my backend API, the user's API. Okay. just throw away my changes before I switch branches. So I'll switch over to that branch, which has added a little bit of code to this API call, hopefully. Okay. So walking through this code a little bit. We just added a few things here. So the way React works, it's a unidirectional rendering thing. You have some state, and you have a render call that will just generate your HTML based on what that state is. So for what we're going to do here, we're going to define a users variable. So we're going to get the users from our API. We're going to store it in this users variable. So this initializes users and a set users call. By the way, I'm using the new React hooks that were recently released, so this doesn't look like React has in the past. It's actually a little bit cleaner. Then I'll have this useEffect call, which will get called when the page loads, and that will fire off an API call to the backend to get my API users. That will then return JSON, and with that JSON, I'll execute the set users call, which I've defined up here. So that will update the state of my app, and then when that state gets updated, this render call will happen, and it will use the user's state here to generate a list of paragraphs, which will show the users and the user email. All right, so these curly braces allow you to insert a little bit of JavaScript code, and then that JavaScript code can generate HTML. It's kind of confusing, but I like it. So with that update, this time let's go ahead and do npm run build. This is my favorite bug that I've come across in prepping for this talk. To fix this bug, I just go cd ... and then cd back into the folder. And then it works. Cool. So that's going to build with the HTML and JavaScript that I have up in this build folder here. And it should finish in a second. Oh, and so while that's building, I actually need to add a URL, an endpoint that will return the index.html. So now Django is going to serve up my React app. I'm not going to use the node development server. So to make that work, what I do is I define a new index view, and that basically just returns the index.html from my front-end folder. And in my settings, the other important thing that I have to do in my settings is add this front-end folder to my static files list. So there I define the React app dir, and then I add the build static folder to the static files list that Django is able to find. And the reason I do that is because this front-end folder has no Python code in it. There's no Django application or anything associated with that. So we just need to tell our backend to return it. So now that we've got that, we can, again, we can run our backend, and we should see a new updated app. And I apologize for the text wrapping. Okay, so there we go. Our React app, it gets the API call. It's showing us the list of users that we have in our database. So that's kind of the basic application. Again, for the dev server, we needed to add port 3000 to the mapping. And then we were able to edit code and reload. And then another thing that I've done here is in the package.json file, I added this proxy command so that when I am using the development server, if there's any API calls that it doesn't recognize, it'll just forward those onto the backend, the Django backend API. So that's something you just need to do for local development to make the setup work. Okay. And then that's the code. This is all for reading offline if you want it to follow through. Okay. So now let's build a production version of this application. So as I've said before, this is all for purposes of making my life easier as a developer, I can edit code and do all those things. But when I publish to production, I want to remove all of these things that I have from the container and build something that's production ready. In particular, when I'm running managed PY run server, this web server won't handle production workload. If you throw a load test at this, it might actually just like hang, and things like that. So now I actually want to exit the development container, and to do that, I'm going to run another command called reopen locally. So when I run reopen locally, that just takes me outside of the dev container, and actually I'll hit close here. So before I do this, I'm going to stop my containers so that the ports don't get used up. Okay. And so I'm going to switch to another branch where I've added a new set of Docker files and Docker Compose file. So I'll switch to the production branch here. And so here I've got these files, the Docker Compose and Docker file that I'm going to use to build my production image. Now there's a few small differences here. So in this case, I still have a local database I can use for testing, but in this case, I've tagged the image with the name of the container registry that I want to push it to when I'm done. And then also I have it pulling environment variables from a .env file. And so this allows me to put passwords and connection strings into a file that is in my git ignore and will not get checked in. And so I'm not putting any of that information into code. And I have this repo comes with a sample.env sample, where it's got, here's the template to fill out. And I can use this, I can just say cp.env sample to .env. And then I'll start to build this. I can actually right click and just say compose up, and that will build that Docker Compose file, and it will run the containers in it. So while this is building, I'll keep explaining some of the different things that I've put into these Docker files. So in this case for the Docker file, before I just put everything into one image, I installed Node into the actual container. In this case, I'm actually going to use Node just to build the front end, and then I'm going to take Node out of the container. And I'm going to do that using a concept called multi-stage builds. So whenever you see multiple from declarations in a Docker file, it's using a multi-stage build. So this first stage, it takes a standard Node container. Then it runs this weird-looking command to apply all the variables in my .env file, and it runs the build. And then I create a new Python container from this pre-built image on Docker Hub. In this case, I'm using an Nginx web server for serving the static files, and it uses a uWSGI server for hosting the Django application. There's some configuration files, but the key thing here is that it actually copies the output of the Node build from that front end, from the first stage, and puts it into the second container. So I've got the output of the Node build, but then I don't end up with the Node runtime or any of that stuff in the production application. And then the last step that I do is I run Python manage py collect static. So this will take all of the static files and put them into a static files folder in my application. And this is the folder that my Nginx web server will serve. And again, I apply the .env file when I'm running that command so that it has the various variables. And I'll explain why in a minute. Okay, so this is probably finished building by now. All right, so if I go to my localhost 8000, there's the production version of the container that I have, so it's good that that works. And then again, this is hosted using an Nginx web server. So if I look at the Nginx configuration, I've got, it says, okay, host all static files. Basically put /static to serve static files from the static files folder. This is the output of the build. And then host my Django application using WSGI at the root on port 8000. Now, I actually have my production secrets in a different .env file that I have saved here, and I'm not going to show you this file, because that's the point. And then that one actually defines, if you look at the sample file here, it actually defines a place to upload static files to using the Django storages library. Because for production, typically I want my files to be available my static files to be available on a CDN somewhere. So I'll start this building again. So now that I've changed my .env file, I have to rebuild everything. So what these environment variables will do is while this is building, it'll actually, when it runs this collect static command, it will actually take all the static files and upload them to an Azure storage account that I have, and that's connected to a CDN. And when that's finished, I'll just reload the container and to show you what that means. So we're almost done here. So right now, when I'm loading these files, all the static files come from my local host. So after this is finished building, and I also remove the .env file from the container afterwards because it has my passwords. So now that this is finished building, when I reload this, all of the static files are now served from AzureEdge.net. And so that will make those files available distributed all over the world so that it's nice and fast for people who browse my website. Okay, so just quick recap. We reopened the folder locally, we added some production Docker files, and we stored our secrets in a .env file. That's an example of what that .env file looks like with my passwords and key removed. And I walked you through what those production Docker files, and there's the configuration for the WSGI server, and that's what picks up the WSGI app for Django. And then I also have, once we have this container built, you can easily just deploy it up to Azure just by using the Azure App Service extension that we have, but that's a bonus. I don't have time to walk through that today. Okay, so that was a tour of attaching to an existing container, creating a new development container, adding a React front end, and then building it for production. The slides and code are available at the aka.ms link up there. That's http://aka.ms. Follow our Python blog for any updates and follow us on Twitter. Thank you so much.
All right. Thank you, Dan.